Bottom line is that carbon dioxide, this is evidence that carbon dioxide does indeed absorb infrared radiation. This is the transmission spectrum from the IR spectrometer. And there's two major regions of absorption, one due to the stretching, the asymmetric stretch, and another one due to the bending. Okay, so here's another IR transmission spectrum. This one's for water. Okay, take a look. What do you think? Is water a greenhouse gas? Yes or no? This is an IR transmission spectrum. And so what we can see here is that there's also two regions of absorption or limited transmission, one up here and one down here. Actually looks like kind of a region and another one. And so clearly the water is also absorbing infrared radiation. Now water, of course, looks like this. So if you had to guess, would you think that this region up here is due to the stretching action or the bending action of the molecules? Remember, stretching is going to be some kind of a stretch, maybe this way and that way, and maybe this one's going in one direction. That would be an asymmetric type stretch. Bending, the whole molecule could be bending up and down and up and down, back and forth. So which one do you think would be due to the stretching? If you look back at the carbon dioxide, the stretching takes more energy, so we would guess that the stretching absorptions are here and the bending absorptions are down here. Okay? So it's a molecule with more than two atoms, so it's capable of undergoing stretching and bending, and we see different absorptions for water as well. If we put other gases that we would consider greenhouse gases, such as ozone or CFCs or nitrous oxide, we would see similar types of spectra. But notice the spectra are unique. They're not exactly the same because each molecule is going to have its own unique spectrum based on the shape and the type of the atoms in that molecule. So each molecule will have its own unique spectrum. It's like the fingerprint of the molecule. All right, so now I think we can answer, what is a greenhouse gas? A greenhouse gas is any gas that can vibrate in response to the absorption of specific photons of infrared radiation. And so those that can do that, carbon dioxide, we've already seen, water, we've seen the spectrum, methane, nitrous oxide, ozone, and the CFCs. They're all molecules that have more than two atoms, so they are capable of bending and stretching, and because there's more than two atoms, the stretches can be asymmetric. Now, the ones that are not capable of undergoing vibrational transitions or absorptions of infrared radiation are these simple diatomic molecules. And the reason why is because in order to have an absorption, I'm just drawing these out. This is chlorine. You have to have a change in the overall electron distribution of the molecule upon the infrared absorption. The vibration has to change the overall electron distribution. And so in the case of these little diatomic molecules, they are, not only are they diatomic, they're linear, but they're symmetric. And so what that means is this side of the molecule looks exactly like that side of the molecule. If there's only two atoms, according to the rules of vibrational motion, if there's only a stretch that is allowed to occur, and so only a stretch could occur, and so the only type of stretching that could occur in this case is going to be a symmetric stretch. The molecule, the overall electron distribution isn't going to change. So since it's only capable of undergoing symmetric stretching, then there's no absorption. All right? So these do not act as greenhouse gases. All right, no IR absorption. Okay, so now we have answered our question, why do not all gases don't absorb infrared radiation, only some do. The absorption occurs as a result of the vibrations that are going on, and the vibrations are bending and stretching, and they have to be asymmetric, so that the electron dispersion across the molecule changes with the bend or the stretch.